Hello, everyone, and welcome to Woolpert's Cloud Audiocast series. My name is Nate.wilhelmi, and with me today is chris.morabito.
Hi, Nate. Thanks for having me.
Great to have you here, Chris. Chris is a product engineer with experience in building solutions in the cloud and experience transforming existing applications to run in the cloud, which is why he's here today to talk about app modernization. In particular, we're going to talk about how an operational business-critical application at Woolpert went from the data center to the cloud. So, Chris, when I say app modernization, what does that mean to you?
Well, Nate, when we talk about app modernization in a cloud context, to me, that means re-architecting legacy applications that were not originally designed to run in the cloud to enable them to take advantage of modern cloud platforms and related technologies. Many organizations, Woolpert included, are shifting away from maintaining their own on-premises data centers to embrace and prioritize cloud infrastructure. Often then, applications that have been running in those data centers, maybe for decades, now need to be adapted to run in the cloud. For example, the application we're talking about today, SmartView Connect, is an application that was running on a Windows server in our Dayton office for about a decade until earlier this year, we re-architected it to run on Kubernetes in Google Cloud Platform.
Yeah, so moving from a Windows VM to a Linux container in Kubernetes was a pretty significant transition. So in that case, does app modernization imply more than just lift and shift?
Yeah, I think so. What we call a lift and shift cloud migration aims to replace existing machines with comparable virtual machines in the cloud that replicate the previous environment as closely as possible. That could be as simple as mirroring a single machine up into the cloud, or as complex as reconstructing an entire network topology. That kind of lift and shift deployment can certainly be a good starting point, and in some cases may be the only option. But app modernization goes beyond that. Rather than thinking in terms of servers with apps installed on them, we want to think of the cloud platform itself as an operating system with various runtimes, resources, and services your application can utilize. To truly take advantage of the power of cloud technology, you likely need to redesign your application so you're not simply trading a room full of servers for a dashboard full of VMs.
So what are some of the benefits of that sort of approach? Why take on the risk of changing the environment that much?
By thinking outside the server to that broader range of cloud offerings, you can take advantage of ready-made services offered by your cloud platform. Leveraging those managed services instead of building everything yourself allows your team to spend their time building the unique things that make your app valuable. A great example of this is databases. You can certainly manage your own database server in the cloud if you want, but the cloud providers have a range of managed database services ready to go. And many of those services have features like maintenance, automated backups, geo-redundancy, and monitoring built in. So using a managed database service could free up your database team to focus on more application-specific tasks like schema design or query performance, rather than spending a bunch of time writing backup scripts or patching servers.
Yeah, allowing your business and your organization to focus on business differentiators really is a great benefit.
Yeah.
So if I want to gain those benefits for my organization, what kind of things are important to consider before starting this kind of effort?
First question you should ask yourself is why? What are the goals you're trying to achieve with the transition? Is there an issue you're trying to solve? A new technology you want to take advantage of? Do you need to improve availability or performance? Or maybe you're just trying to satisfy an IT mandate. It's also important to consider constraints. What other systems does this application interact with, and will it need to continue to interact with them? How much downtime can you tolerate during business hours, off business hours? Do you have to meet any regulatory requirements? And perhaps most importantly, what is your team's expertise? What is your capacity to manage the solution? Keeping these goals and limitations in mind will help you shape your architecture, select the right technologies, and define your deployment strategies. Knowing what targets you need to hit and which you can miss may keep you from over-engineering a solution only to realize that it's too expensive to run or too complicated to manage.
You mentioned that lift and shift can be a great place to start, and that's the first step we took with SmartView Connect Cloud transition. Can you elaborate on why we chose that approach and what the process was like?
Sure. First, though, I'm going to plug a previous audiocast you did with Dylan, where you described DevOps and the value that those practices bring to managing applications and infrastructure. I'm not going to rehash all of that here. So if folks want to learn more about DevOps, they should definitely go back and check that out. But I mention that because, long story short, SmartView Connect had few to no DevOps practices in place. So before we made any major changes to the application, we wanted to improve the patterns and practices around building and releasing it as it was. When an application like that has a lot of interconnected components, it can be daunting to try and re-architect it all at once. You're sitting there staring down a massive redesign with a ton of changes. And then if something doesn't work, it's really hard to figure out where you went wrong because you changed so many things. So that's why I said a lift and shift can be a good place to start. By replicating that existing environment as closely as possible, you can get up and running in the cloud with minimal changes. And then once you've established that baseline, you can start iterating on it and incrementally evolve toward the architecture you ultimately want. In our case, we knew in the end we probably weren't going to be running on a Windows server, but we started there so we could build knowledge and confidence in that existing runtime environment, just now in the cloud. And by adding in some of those missing DevOps practices like automated build and test pipelines, infrastructure defined as Terraform code, we gave ourselves the ability to easily spin up test environments and more confidently make changes to both the application and its infrastructure.
So folks might be surprised to hear us talking so much about infrastructure in this episode about app modernization.
Maybe. But one of the keys of the DevOps mindset, one you've emphasized a lot for our team, Nate, is shared ownership. Re-architecting an application with a cloud-first approach means taking a more holistic view of the application together with its underlying infrastructure and creating strategies for managing changes to both, rather than application developers throwing code over the wall and expecting infrastructure team to figure out how to make it run, or conversely, the infrastructure team choosing the runtime environment that developers have to work within. Having fuzzy boundaries between those roles and working collaboratively ultimately results in a more reliable system. And cloud platforms have so many options for compute environments now that your runtime choice will likely end up dictating a lot of infrastructure security and deployment patterns as well. So it's becoming increasingly difficult to separate code from the infrastructure that supports it.
There are certainly a lot of services to run code these days, from virtual servers to serverless functions. How do you compare these options when redesigning an application's architecture?
When I look across what you might call the server to serverless spectrum, I see levels of trade-offs between management complexity and control over the environment. At one end, you have virtual machines where you control pretty much the entire system, but that control comes with a lot of complexity. You have to install dependencies, patch the operating system, manage remote access and firewall rules, etc. At the other end, you have serverless functions, something like AWS Lambdas. In those environments, you have very little control outside of your code, and resources are limited. But much of the system is managed for you, so they're very easy to deploy. And you can picture platforms like managed Kubernetes or container services lie somewhere in between that on that spectrum. So deciding on a compute environment often comes down to system dependencies and the shape of your workload. A lightweight service with a few dependencies that's invoked infrequently may be well suited to the simplicity of a fully managed serverless environment. Conversely, a long-running service with a bunch of system-level dependencies might require more control over that system and would benefit from the added complexity.
Yeah, we did a lot of work on Stream Raster's data ingest pipeline before we found that right balance, didn't we?
We sure did. We went through several rounds of redesigns before we found the right compute environment. Early on, we tried to do all the processing serverless in Google Cloud Functions, but the workload's requirements were beyond the limits of resource allocation and execution time that are available to us. We tried to make it work, but in the end, it just wasn't reliable. So then we took a pass at using Cloud Run before ultimately landing on Argo workflows inside of Kubernetes. We found that for that particular process, we needed more control over resource allocation and execution deadlines than we could get with the serverless platforms. So Argo gave us the control we needed while still providing the benefits of not having to manage the machines directly ourselves.
What are some of the application design principles that aided those transitions between compute environments?
One design factor was separating the invocation of the code from its core functionality. Our processing pipeline could be invoked locally via command line, which was great for local development, or we could swap in HTTP triggers or PubSub triggers as we needed them for different services without redesigning the core process. Another consideration was taking an API-centric approach. All of the data we process comes from REST APIs, be they from Google Cloud Platform services or internal services we developed. So the compute can really live anywhere, and the app just has to be able to make HTTP requests. We don't have to worry about local disk being available or direct connection to a database. And finally, a key technology that enabled that flexibility was containerization. In your DevOps audiocast with Dylan, you referred to containers as the lingua franca of shipping code. And we've really taken that to heart. We deploy the same immutable container image to each environment and handle the differences with environment variables or other configuration mechanisms. And even when we were working environments that didn't support containers, like Google Cloud Functions, we still took a container-like approach and constructed a zip archive of source code that was tagged and similarly deployed as is to each environment. Containers have been a real game-changer technology for application development. Having that kind of precise, isolated control over the app's environment and effectively running the same environment on my personal laptop that will ultimately run in the cloud makes testing a lot simpler and makes deployment much more predictable.
So with all these changes that were done to this application, how much interruption did the business experience?
Thankfully, very little. Most of the downtime we had was either unavoidable, outside our control, and all of it was scheduled during off business hours. Our first major disruption event was for the initial cutover we did from our on-prem environment up to the cloud. We had deployed the app and tested it with a database backup and a temporary domain name. But when the time came, we had to export the latest database version and ultimately change a DNS record to redirect from the on-prem environment to the cloud. And that DNS change was actually the worst part. It took a lot longer than expected for the records to become consistent. So that was the first time we had kind of that scheduled downtime. It was off hours, so we really didn't disrupt the business, and we were able to announce it in advance and plan for it. Our second downtime event was, again, DNS related. That was when we cut over from our lift and shift Windows environment over to Kubernetes. We had to make another DNS change to swap out an IP address. And frankly, if DNS hadn't been a factor, we may not have had any downtime at all, or it may have only been, a minute or two. Adopting DevOps practices has really allowed us to confidently change the application and its infrastructure during business hours and make zero downtime deployments routine.
Yeah, that's great. The problem usually is always DNS.
Always.
Well, that's it for this episode. Thanks again for joining me, Chris, and thank you to everyone who's joined in, whether you're considering app modernization or just looking to figure out how to get your workloads moved to the cloud. We hope this conversation resonated with you. Chris, how can listeners get in contact with us?
Folks want to contact us, they can reach us at cloudsuccess@woolpert.com.
Thanks again, everybody, and have a great day.